Hello class. This standard, ECO.3, is about knowing the effectiveness or the efficiency of energy transfer. So when it goes from primary producers to the next steps of the food chain or trophic levels, how effective is energy transfer? And the answer is right here. It's only 10% efficient. So looking at your next slide, energy transfer between trophic levels or levels of the food chain is only about 10% efficient. Production efficiency, only a fraction of energy is stored in food. Energy used in respiration is lost as heat. And remember, energy flows, not cycles within ecosystems. So, what do I mean by it's only 10% efficient? So think about this plant material that this caterpillar is eating. So if this plant had, say, for example, 200 joules of energy in it, okay, it loses some of that energy because it uses it. It's going to use some of that energy to actually grow, and then if it's eaten or travels on, some of it is going to be not even used. Like half of it is just into poop. It's not assimilated. It's not even used. So you could see a lot of this energy. If I'm looking at some of these, it's equally distributed. You don't get all the energy eaten. Or another way to put this: if this plant had 100% energy, this caterpillar is not going to get all 100%. Whatever eats this caterpillar is not going to get 100%. Like every time somebody eats it in the food chain, only 10% travels up. If you need another visual, if you look at the next slide, of the 1 million joules, this is a unit of energy of sunlight. Like plants only get 10,000 of it. Primary consumers only get 1,000 of it. The ones that eat those primary consumers only get 100. And then if you're a tertiary consumer like us, or this one is a bird, you only get 10 joules of the 1 million we started with. Once it finally travels down every 10%, we barely get anything. So an ecological pyramid sort of also gives insight to food chains. This is examples of some pyramids. Loss of energy limits the number of top-level carnivores. So we talked about this in the previous chapter, but depending on how much energy that your ecosystem has, it tells me how many carnivores you're allowed to have. So for example, this one says number of individual organisms. This is a pyramid of numbers. In a bluegrass field, we have 5.8 million primary producers. Since we lose every 10%, this particular bluegrass field only has 708,000 primary consumers. Again, losing 10%, this particular field only has 254,000 secondary consumers. And because you lose so much energy from each individual step of the trophic levels, this particular ecosystem, this field in Michigan, its carrying capacity is only 3 tertiary consumers. That's telling you why food chains are shortened and lengthened. Really, most food webs only have 4 or 5 trophic levels. So that's another example why you don't have 20 links in the food chains, because energy is lost. 10% is retained, 90% is lost every time you go up on a food chain. And the last slide, these dynamics of energy also have important implications for the human population system. So here's a primary producer. If we just ate vegetables, this one's corn, or primary producers, our population can actually support a lot of people. We could support this many people. And it might be hard to understand or grasp, but if cows eat, plants, and we only eat cows, really, honestly, we could barely support, we could compare these 2 blocks, we could only support so many people on this planet. So, you may have heard, going vegetarian, going vegan is good. Good for your body, good for health. Another good reason is that it also supports more people. We wouldn't have that much world hunger if we sort of shifted to a vegetarian diet. So anyway, that's the standard. Hope you guys enjoyed this video, and I'll see you guys in the next one.